All right, let's kick this off. Good morning. My name is Meg Detloff, and I work for USGS PNAMP. Thanks for joining us for the April PNAMP Fish Monitoring Work Group meeting. Slide, Sam. Before we get started, I'd like to go over a few meeting logistics. Unless you are speaking, please turn off your camera and your microphone by clicking the icons on your Teams platform. If you have questions, please use the chat function or raise your hand and unmute yourself. We can mute you, we cannot unmute you. We are recording the meeting and it will be available on our YouTube page, hopefully in the next couple of days, or at the beginning of next week, actually, since today's Thursday. If you are having trouble with the chat function, here's a couple of troubleshooting tips. Slide. Sorry, I can't see the deck on mine. If you're having trouble, oh, thank you, Amy. Sorry, guys. If you're having trouble with the chat function, here's a couple of troubleshooting tips. Try leaving and joining again. Use a different browser. Edge usually works better for Teams than Chrome does, or try the desktop version instead of your browser or vice versa. If you don't have access to the chat, always feel free to unmute yourself to comment or ask questions. Slide. PNAMP commits to fostering an open and welcoming environment, so please remain respectful. Slide. I would like to acknowledge the Fish Monitoring Work Group leadership. Names are associated with the tasks they have previously and currently lead. These folks are willing to help solve issues in our community, and we are grateful for their help. I'm going to hold on a second. I'm getting feedback. Are you guys hearing it? Okay, I'm just going to keep going then. Apologies, everybody. This is a different setup for us, so we're making the best of it. So what you guys are seeing on your screen is the Fish Monitoring Work Group leadership. The names are associated with the tasks they have previously or currently lead. These folks are willing to help solve issues in our community, and we are very grateful for their help. The core team, if you can't tell with the coloring on there, it consists of Casey Bleesner, Marika Dobos, Laura Erickson, Nancy Leonard, Russell Scranton, Mari Williams, and Jen Bayer. To help me keep track of participation, feel free to open up your chat and introduce yourself with name and organization. This also helps you acquaint you guys with the chat function, so you can kind of get a feel for it. Next slide, Sam. And while you guys are doing that, I will quickly cover today's agenda. We'll kick off the meeting with updates on current tasks. Next, Tyler Hessler, a PhD student in the Missouri Cooperative Fish and Wildlife Research Unit, will present development of a mid-sized river habitat sampling protocol, followed by Q&A, and then we will close the meeting with a quick wrap-up and next steps. So next slide. Right. Okay, so task team updates. These are overviews of progress. If you're interested in learning more about a particular task, visit the project page on the PNAMP website, and I'll have somebody drop that link in the chat for you guys. And then just select a task. And some of our previous tasks are also in there, so if you're interested in some of the stuff we've done before. And then either myself or one of the leads will give a task update. And then I'll pause briefly for questions and comments. If you have a question after we move past the task, type it in the chat and Jen or Amy will circle back after all the updates are complete. Okay, next slide. Okie dokie. So carrying capacity standards. Currently, this task is working on a paper reviewing carrying capacity estimation methods. These methods include habitat expansion, stock recruitment models, quantile regression, individual-based models, and food web modeling. Authors of the paper can be seen on the slide, and the current draft is under review by the authors and Morgan. And then the rest of the task leads, we're working on refining the discussion and massaging the paper into a succinct product. We're hoping to have some external review by mid-2025, just kind of depending on the pace of things right now. And does anybody have any questions on that? And Amy will let me know if there are questions. Okay. Okay. All right, and Morgan's here too, in case you guys want to ask questions of him, since he's the lead. Alrighty. And obviously I told you guys we'll circle back, so next slide, Sam. PIT tag array data and analysis focuses on documenting and recommending improvements to data management and analytical methods and tools for PIT tag data. In 2024, task leads identified some key needs from the PIT tag community. Standouts were a one-stop shop to help people find resources for PIT tag data and analysis. Another suggestion was a series of PIT tag specific webinars or hands-on workshop to help people with analysis. And at long last, the webinar series will launch next week. So ideally, we're aiming to highlight good tools for all skill levels and also help people streamline their data management and formatting for their specific needs. We also will discuss a few of the data repositories and where tools can be found. And next slide. So this slide gives you a peek at the next 5 weeks. We will host a meeting every Thursday from now until May 22nd from 10 to 11:30. And then after the presentations are done, we'll have a 30-minute optional office hour. If folks want additional help or to ask specific questions of the presenters, they're all going to hang out. So as soon as the questions die off during the office hour, we're just going to end the session. So make sure you tune in because you don't want to miss out. Questions on the task of the webinar. Thanks for dropping the Fish Marine Workgroup project page, Jen. So if you guys see that in the chat, you can check out the project page. All right, next up, I'm going to hand this over to Mari Williams of PSMFC and StreamNet, who's going to talk about the terms and definitions used in CAP data standards task. Go ahead, Mari. Mm-mm. Mm-mm. Do you want to put my headset on?
There. Okay.
There you go.
All right. Sorry about that. So I am going to give the update today for the terms and definitions work task group. So we started at the end of last year. And next slide. So the task came out of the 2023 CAP workshop and user feedback that we had gotten on different terms not being immediately recognizable or misinterpreted. And we have been working to develop unique terms and unique definitions in order to not reuse terms for multiple different things. Next. We got together and had some staff flag issues as well as the reported options that we had from the CAP workshop. But this is pretty quick, so see next slide. We did follow the DES revision and development and revision procedures as outlined in the document available on the StreamNet CAP website. So by the end of January, we had developed a short list and we sent out a survey that hopefully you'll remember getting an email about. We'll be repeating that. So after there were 134 items that were recommended for adoption. And next slide. So we sent out a survey on the minor DES changes, and then at the end of January this year, we had a meeting with the DDT teams, that's the Data Exchange Standard Development teams, for both natural origin DES and the hatchery origin DES. So we had 80 different changes surveyed. A lot of these are multiple uses of the same term across the DESs. Through the survey, we had 61 unanimously adopted and 19 requested for further review with the DDT or via another survey with just a couple of minor additions to definitions. So at the DDT meetings, we reviewed all of the recommended adoptions from the small task group, and we got through, and so this was then minor changes and major changes, which per the protocol require DES meeting and agreement on that. So we have 25 of the natural origin DES items reviewed with recommendations. We have 17 for the hatchery DES, and the hatchery DES update that had been being compiled since we launched that DES in June 2023 was adopted, and the group also chose to include whatever was unanimous in the minor DES changes survey. So there's 16 recommendations from the terms and definitions group that are going into the new version of the hatchery coordinated assessments DES. Next. So I'm going to make another Microsoft survey form for the 25 natural origin DES items that were reviewed and recommended to adopt by the DDP, so that a larger group can potentially weigh in on any issues that you see, and 17 of those for the hatchery coordinated assessments. And I'll include a couple of things to be resurveyed from the first round of surveys. So once those are cleared through the surveys with consensus, they will add to the developing natural origin DES next version. And if they aren't done by the time we are releasing the currently almost done hatchery DES version, then they will go into the next. They'll go into the development DES for that. So once that is done, we update both the DES and the StreamNet data services so that you can have access to all the updated terms and definitions along with new functionality in each DES iteration. I think that's the last of mine. Okay. Thanks.
Awesome. Thanks, Mari. Does anyone have any questions for Mari? And if not, this is the last update. So if you have questions about any of the previous tasks, like, go ahead and type them in the chat or raise your hand and unmute. All right. You guys can obviously reach out to us one-to-one if you have questions. We can get you connected to the right people. All right. Let's get to the fun part of the meeting. I'm honored to introduce Tyler Hessler. I mentioned before, he's a PhD student in the Missouri Cooperative Fish and Wildlife Research Unit. And with that, Tyler's going to take control of the screen and show you guys all the cool work he's been doing.
See if I can figure this out again first. All right. All right, we're seeing the right
Perfect.
screen. Okay,
yep,
cool.
Looks great.
Are you guys in the middle of it? Let's move that. All right. Thank you again, Meg, and the rest of the Fish Monitoring Working Group for inviting me to talk today. It's always really exciting to talk about this work outside of Missouri. And I think it was great talking at AFS last year, where I think you guys heard about this. So hopefully you'll get some out of this this progress that we've had so far in the development of a mid-sized river habitat sampling protocol. If they'll let me go. There we go. This introduction isn't going to be new to anyone here, so I'll kind of go quick, but I just wanted to set the stage of why this project is important. Obviously, there's a lot of threats to our freshwater fisheries across the world, from overfishing to pollution and climate change, and arguably the worst of them all, habitat degradation or some kind of alteration. And habitat's always changing from a variety of different means, whether it be natural events like flooding and hurricanes and other things like that, and in a lot of cases also anthropogenic, like removal or construction of dams, any kind of remediation projects. There's always something that's changing habitat, and with that we need good standardized protocols in place that we can go out and rapidly assess habitat to make the most up-to-date management decisions possible with accurate data. But with that, we as fisheries folks know that sampling habitat can be tedious. And a lot of times, particularly in my experience and talking with other folks as well, sampling habitat is kind of an afterthought. It might be something if you have time to sample at the end of a project, you go ahead and do, or you might add it, if there's a little bit time day to day as you're doing other tasks when it comes to any kind of fisheries work. But there are protocols out there, especially for these non-weightable systems in order to assess habitat. One of the more popular ones that's utilized across the states is the EPA's physical habitat characterization for non-weightable rivers and streams. Just a couple examples of what that looks like depicted here. So basically, you can select a section of river, you divide that river into 10 equal segments, giving you 11 of these transects essentially. In each of those transects, you can measure a lot of different habitat metrics, including things like substrate and woody debris and bank angle, which you see in that data sheet on the right. And then you essentially repeat that for each of those transects. So you have these discrete points where you're measuring all these variables and kind of extrapolate out from there across the site. There is a little bit more continuous survey too, as you float down the middle. Many folks will use that to gather depth as well as velocity data, and maybe some other things you might be able to capture along this continuous transect. But in the end, it's not nearly as continuous as we would like, especially in riverine systems that are often really unique and change very rapidly, both latitudinally and longitudinally. So we need some methods in place that can measure a more continuous level of these different metrics of interest to us. And I'm hoping the work that I talk about today will kind of play in. So a lot of the reasons why we have these discrete transects and things have been set up the way they are is, one, we just don't have the resources, and two, we don't have the time either to do a lot of this habitat sampling. So that's where we at the University of Missouri and the Missouri Department of Conservation came together, addressed this need, particularly in the state of Missouri, but we know it's a problem elsewhere, to develop a more standardized protocol that can be used efficiently to gather a more robust data set. And one of the first things we did was send out a sampling questionnaire back in 2023 to a range of fisheries and aquatic science-minded folks in the state, both at the federal, state, and academic level, and just asked their general opinion on what they thought they needed to assess habitat in these systems, and just other opinions on what metrics were most important for their work. And a couple of the bigger things I'd like to point out from that survey are these plots listed here. The first being, we asked them how long do they think they could spend sampling a site. And the overwhelming majority said they'd like to spend a day or less sampling habitat at any individual site. And then a lot of times it was even less than that. They would have put a comment saying they probably can't spend more than 4 or 5 hours at any one site, which was something that really stood out to us and really pushed us to come up with gears that we could do with a single trip out in the field where we don't have to spend multiple days or overnight trips to get habitat sampling done. And then second here, these plots on the right just show the gears that I'm going to be talking about today. We wanted to know how comfortable or how much experience folks have with these gears. And to no surprise, we had a wide range of experience with side scan sonar. It's becoming more popular for folks to use. It's common on most of our sampling crews' boats, and it's becoming more popular and relatively cheap to use. So no surprise there. And really no surprise with the other gears. We thought there might be a little experience with these other gears I'm going to talk about today, but overall, most folks don't have a ton of experience, especially fisheries biologists and fisheries management biologists with using these gears. But we really do think these gears can offer a lot to you, and they're not super difficult to learn how to utilize, and you can gain a lot of useful information, particularly habitat-wise, using these gears. And with that, there's 3 main objectives for this project. The first, again, is to develop this habitat sampling protocol, particularly utilizing remote sensing technologies. The second objective is cooperation with their partners at the computer science department here at Mizzou. They're developing deep learning models that the end goal being to automate a lot of the processing of the data when we come back from the field. So we're hoping with this project not only to present gears that are going to make it easier and faster to sample in the field, but also provide tools and other ways to process the data quickly when you get back, so you can get actual hard numbers in hand much quicker than if you had to do it all by hand each time. And then lastly here, this third objective is particular to my dissertation. I won't talk about it much today, but just we wanted to utilize this sampling protocol for something that I was interested in, and just looking at how temporal and spatial variability in riverine habitat changes over time due to flooding events. So I'll formally introduce you guys to the 4 gears that I'm going to talk about in this talk today. If you want to follow along with the table on the top right, I'm not going to go into detail much there, but it kind of gives you an idea of where we think these gears are useful in terms of measuring different metrics related to habitat. So we have our aerial drone, which is that top left image, obviously. The top right might not be familiar to many folks, but that is a 360 camera. This particular model is one that Google uses to do like Google Street View. So if you imagine you just set that on a boat, you could have a street view, in quotes, float of a river, and you could get a lot of really relevant information from those 360 images. And then the bottom left is our side scan sonar unit. We use Humminbird to get a view of what's going on below the surface of the water. And then lastly here is an ADCP unit to get us important information about discharge, velocity, and bathymetry across these sites as well. So this work is right now being primarily done in the state of Missouri. We have a small pilot project in Ohio with the removal of the Cuyahoga Dam. I won't talk about that today, but there is a little bit of work outside of the state that we're hoping to get more involved with. We have 10 sites located in Missouri. We have 5 in our northern plains portion of the state and 5 in our southern Ozarks. State's kind of split right down the middle by the Missouri River, and ecoregions are kind of split by that the river as well. So anything north of the Missouri is more low gradient, highly silted, sandy systems, and then our southern portion is more high gradient, cobble boulder streams. So the goal with selecting these sites was to get a variety of different habitats that we were sampling in to ensure that these gears can work reliably across different conditions that individuals might come across within the field. And this term mid-sized rivers really is a catch-all for anything that's larger than our wadable streams, but not quite our great rivers. And in Missouri, that's a good portion of our water. So there's definitely a need to sample these systems more thoroughly. That just hasn't been done in the past, just because there's so much water to cover. But we're hoping the gears that we talk about today are going to make that a lot easier to do in the future. So I'm going to move on to talking about our sampling design, as well as go into detail a little bit more about each of our gears and the data you can generate with those gears. And this first slide here is just what a typical day for us looks like sampling in the field. So this figure on the left shows the variety of different transects and surveys that we do with our gears. And the only one that we really don't have to do on a boat is our drone transect. We can do that from a parking lot. We can do it from the bank. If we have to, we can do it from a boat, especially during flood conditions where we might not have a lot of available area to land on actual solid earth. But everything else we're doing is on the boat, obviously. So we use the ADCP to measure discharge. And what I'm going to talk more about today is our what's called a serpentine transect with our ADCP unit. And that's these orange zigzags that you see going down the length of this site. There's actually 200 of those transects. And the goal with that is to give us really high resolution depth and velocity data distributed across the entire site of interest. And then lastly here is this single transect that we do down the middle of the river with both our side scan and our 360 camera units. These two gears work great together. You can set up the side scan, and folks who are familiar with side scan, you can see both banks really nicely, and you can also have the camera recording above the water as well. Do a single float, and you can get a lot of information about what's going on above and below the water. So like I mentioned, I'm going to go into a little bit more detail about each of these gears and just data you can get from these gears and why that might be relevant to habitat related issues. The first I'll talk about here is our drone imagery. So like you saw in that previous slide, we do these transects that run parallel to the river. When it's running these transects, it's looking straight down and taking imagery like you see here. So the camera the origin is in the middle of the picture, obviously. We take images about every 3 seconds, so there's a lot of images being taken, and there's a lot of overlap in those images as well, as you can see here. It moves a little bit further downstream and takes another image. But that overlap is important. We look to have anywhere between 75 and 85% overlap between these images. That overlap is really important for software when we get back to the lab to stitch those images together. So most sites, anywhere between 300 and maybe close to 1,000 images, depending on the site, are generated. Software stitching them together, and then we're left with what's called an ortho image, which you see here. So this is really rough. We haven't cut buffers to any of the site or anything. We usually clean them up a little bit, but this just gives you a good idea of what those images can look like when you stitch them together. It essentially looks like you're just looking at a satellite view of what's going on at your site, but at a lot higher resolution. And you can do this whenever you want, really. It takes maybe a half hour to an hour to run the whole site, and then you can get really quick data about different habitat of interest at whatever sites that you're interested in looking at. But you can imagine there's a lot of stuff you can start to pull from this imagery. We can look at riparian usages, things like agriculture use, as well as tall canopy, or some of the metrics that we're interested in identifying, as well as, of course, lots of in-stream habitat as well. And this image doesn't do it justice, but it's so zoomed out. But this image is the same resolution as those images I showed in the last slide. So when you zoom in, you can see every single branch. You can roughly see substrates at the altitude that we're flying at. So you can start to classify different substrate classes that are visible. But obviously things like woody debris are super prevalent in these images. You can start identifying not only counts, but areas, which we're starting to think area is probably a better way to describe woody debris when it comes to how fish are using them. As well as, again, other things like sandbars and gravel bars, too, that might be present in the river. And so second here is just an example of what this 360 imagery that we can generate looks like. So we're using a 360 camera. You can put it in a 360 image where you're like in a fisheye and you can move around. It's not very useful to us when we're looking at and trying to analyze what that habitat looks like. So we use this version of it where it's spread out on a 2D image. So just to get folks oriented, the middle of the image is looking straight down the river, and as you move left and right, you're moving to the port and starboard side of the boat until eventually you're wrapped around to the back of the boat, which is the very edges of the image. And you can imagine there's a lot of similar habitat that you can start to derive similar to the drone imagery. You're just more limited in that you can't usually see outside the banks, or obviously in a lot of cases trees are limiting our view into the riparian corridor past a certain extent. But you could also look at in-stream habitat like woody debris and things like that too if it's present. And it just gives you another view of what's going on at these sites at a higher resolution. Obviously, you could start to correlate if you see something on the drone imagery that might not be entirely clear. You could verify it with the 360 imagery if you're taking both of those together. I will note one of the bigger difficulties with 360 imagery is we don't really have a way to scale it. So all of these different habitats we're looking at are just relative proportions at this point. Like, it's really hard to start measuring volumes and lengths when you're just looking at this indefinite image that doesn't really have a start or end per se. And then thirdly here, just our last piece of imagery before I talk about ADCV, which is a little bit different in how we approach it. I'll just quickly explain side scan for anyone who doesn't really know how it works. So unlike traditional sonar, which is looking downwards and getting an image right below the boat or slightly outwards from the boat, side scan is the sonar is pointed more outwards. So it's pointed, in our case, towards the left and right banks. And so as we're floating downstream, we can get an image about what's going on across the whole swath of the river. And this blown up image you see on the top right is just an example of what looking outside the starboard side of the boat would look like. So the left part of the image is the path of the boat, and then the very right side, you can see where the bank is formed, and the really dark area is essentially no data. It's the sonar looking outwards past where there's no water, so we can essentially ignore that. But as you start to look at more side scan data and you get more trained using it, you can start to pick out a lot of important habitat features, especially substrate type and size from these images. So we can look at things like fine areas where we might have sand, silt, or clay versus larger substrate like rocky boulder in this case. There's also obviously other objects in the water that we can see, fish being one of them, but other things like woody debris and other structures that might be important for fish habitat can start to be identified with this imagery. And much like the drone imagery, we could start to label the entirety of what the bottom of the river is composed of with these different classes of interest that we have listed here. So kind of moving away from imagery and talking about something that's really important, but we're obviously having to tackle a little bit different than the process we're using with our imagery data sets that I've mentioned so far. That's our work with our ADCP unit. And I wanted to mention particularly this serpentine unit because it's kind of an unorthodox way. It's been done in the past, but it's not like used all the time. Obviously, most people use ADCPs to measure discharge, but it also does a really great job at just showing us velocity and depth across the range of a site. And like I mentioned before, we're doing 200 of these transects. The hope right now is that we're doing way more than you'll ever need to do, and we can start to scale back the amount of effort we need and start to recommend to folks how much effort, how many transects do you actually need in order to answer a wide range of different questions and objectives. And with ADCPs, the raw data isn't always the greatest thing to work with, and especially with like fisheries biologists who might not use it day to day. But fortunately, there's some great tools out there. The USGS having one of them with the velocity mapping toolbox. This tool is great in that it can generate CSV files from the raw data that you get from the ADCP, where each row essentially is a georeference point of depth and velocity. The ADCP is taking measurements approximately every half second, so there's tens of thousands of points you have. Those CSV files can then be imported into various GIS platforms. We use ArcGIS Pro, where you can start to make these really awesome maps, using any kind of interpolation method that you want. We particularly use kriging methods, but you can start to look at bathymetry maps as well as velocity heat maps at these sites. And there's just so much information from this alone that you could start to derive about habitat and habitat preferences for a wide range of species you might be interested in looking at. And so like I mentioned before, we're running 200 of these transects right now. And that can take quite a while. I'll be honest with you, since with running an ADCP, you have to go at a snail pace, no faster than usually 2 miles an hour in most cases. And with that, it can take anywhere from, with our size sites, to 3 to 8-ish hours to sample a site, which can be excessive. But again, we wanted to oversample so we can start to scale back and show folks what they can expect to get with these varying degrees of effort. And the way we're initially proposing that is through these simulations where essentially we just remove X number of transects. So in the middle case, we remove 10% of the transects, and in the far right, we remove 75, or we're only left with 50 transects in that far image. We rerun those kriging interpolations, and we start to compare how much data or how much error is introduced to the data compared to the 100%, or what we call true data, which is on the far left. We do this anywhere between 10 to 90% of the data retained, and we really want to get this fine scale look about when do we really start to see an uptake in error, both in terms of bathymetry as well as velocity across these range of sites. And is it similar across these sites? We also want to kind of figure that out as well. Okay, so kind of moving on from the technologies that we're using for this work, I want to just briefly mention these deep learning models. That was objective 2 in this project. We use these models particularly to hopefully automate the process of identifying habitat with our drone 360 camera and side scan imagery. When I say we, that's mainly our computer science collaborators. They do a great job handling all the random questions and data that we give them. We go out and sample and help them label the data with these different habitats of interest, and they've done a really great job at helping us reach these different objectives and questions that we want to be able to answer with these models. But I do think it's really important for this project, so that's why I wanted to mention here today, because this will be a huge component to this protocol when it's done, is to have these tools that are hopefully available as some kind of like online Shiny app or something like that, where you can upload your data and then get out metrics of interest really quickly, or hopefully relatively quickly after these models are ran. And again, I just wanted to quickly show the workflow for that. I'll use the drone imagery as an example here. Originally, we thought, hey, we'll just grab some publicly available AI models out there and tinker with those until we find one that works. What we found was, yeah, these models do a pretty good job, but they weren't doing as great of a job as we'd like, particularly with some troubling classes of habitat. So what we ended up having to do is generate this workflow where we have multiple models that are introduced, multiple steps that add new rules or change the labels at that point. So the next time it's labeled, it does a better job at labeling it. Just an example with that, gravel sandbars look very similar to the roads and gravel roads and stuff like that in the riparian corridor. So we had to introduce this step 2, which is this bar area adjustment, which accounts for the how close the area is to the river and the size of it to help determine which of these classes it should actually follow in. And that's really helped to improve the overall accuracy of these models. This is just a confusion matrix, essentially, of just early on as we've been using this workflow for the drone imagery. I'll point you all to the 4 rows at the bottom that are highlighted. These are some of those steps that we've had to introduce to hopefully improve the model. Like I mentioned before, if you go to that far right column bar, early on we were terrible at predicting PAR, only about 56%. But by adding these steps, particularly step 2, but it improved even after that, we were able to get almost 92% accuracy in the end with that class. And across all the classes we were looking at, we had greater than 90% accuracy, which was really great. I don't think we ever expected to be quite that high overall accuracy. We were hoping, close to 90% overall would have been great. And then there would obviously have been some tinkering by the end user afterwards, just to make sure everything was as accurate for them as possible for whatever use they were going to have of it. But starting out with such great overall accuracy is really going to help improve the amount of time folks have to look afterwards to make sure it's doing a good job to answer whatever questions they might be interested in. We're kind of just wrapping up here, just some next steps for this project that are hopefully going to lay out over the next couple of years. You might have noticed, I talked a lot about woody debris early on, but it wasn't in that workflow with the drone. What we found with woody debris, it's just too small to run with these what are called segmentation models. They work to classify larger metrics of interest. So think about like a whole bank full of like tall canopy or the water, whatever it may be. And when you zoom out, woody debris is relatively small compared to the entire image you're looking at. So we're actually looking to use object detection models to run alongside the classification models that I've mentioned previously to identify woody debris more accurately, because like I said, woody debris can be very tiny and the when you compare it to some of these larger classes that are involved in that workflow mentioned before. We also have the seasonality component we're interested in. So we sample throughout the year. We sample both leaf off and leaf on. And there's obviously pros and cons to sampling at various times in the year. This is a great example of, tall canopy is very obvious in the summertime when there's foliage on the trees. In the winter, you can probably guess where it's at, but it's not nearly as evident. So there's obviously some pros and cons right there. But also, if you sample and leaf on, you create a lot of canopy cover over the river, and then a lot of times that can be troublesome, particularly with our smaller rivers where maybe even up to a third of the total surface area of the water is covered by trees. The area that's covered is usually where woody debris is going to be present, close to the banks. So if you can't see that, you're usually going to have an underestimation of the amount of woody debris in your area. So that's where you might have to come back at leaf off to get a better view of what's going on, and maybe have both data sets to help complement all the different metrics you might be interested in gathering. And like I mentioned before, we really haven't started to dive too far into this yet, but I'm really interested since we have so many these sampling events, we sampled all of our sites between 5 and 8 times already since 2023, and we'll probably double that across all these sites by the time we're done. We have really fine resolution data about how habitat is changing throughout the year, in particular to flood pulse events. We line it up with gauge data, see when one of those pulses comes through, and then we go back and resample, and we can start to see how that habitat is changing in a relatively quick amount of time. This is just an example I want to show that I thought was pretty cool. We had a flood that was about 10 times higher than the 95th percentile, which is kind of our threshold, come through, fell a big tree into the water that is creating not only new woody debris habitat for fish, but it's also changing hydrologic flows around the tree, creating new areas of deeper pockets, as well as changing how substrates distributed through that area as well. And again, if you apply this across a whole site, you might have dozens to hundreds of these events happening, and that change could be pretty high, when you think about the size of these sites that we're sampling. And just lastly here, as far as developing the sampling protocol, we need the end goal is really to determine how much effort we need to use with these gears to give folks the amount of data that's going to be sufficient and adequate to answer whatever questions they might have. And we know that this protocol should be flexible enough that whatever objective or goals you have set, you can adjust what gears you use, how much effort you use in those gears to answer the question without having to overdo it, essentially. ADCP is a great example. If you don't have to sit out there and do 8 hours of ADCP, you're probably better off doing something else, gathering habitat with the drone or something else that might be more useful. But with that, one of the bigger things we want to know, we have these set sites in mind, but can we sample smaller areas that are still projecting the same proportion of, let's say, different substrates as larger areas? A great example is we have a river assessment monitoring program for smaller streams where they're looking at long-term change in these sites, where they might be sampling just a few sites in each watershed or ecoregion and just monitoring those over time. With these kind of studies, if you can get away with a smaller portion, you can sample a greater number of these smaller portions throughout watersheds to give you an idea of the overall habitat in those systems. So can you get away with sampling a third of one of these sites or 2/3 of a site to represent the whole site like we have been measuring so far? And again, really determining how often is sampling necessary. And I think that question is really going to be answered as we start to dive further into looking at how much change is happening between these sampling events. That'll help us to tell folks how often should you actually be sampling, depending on whatever your question is that you're interested in, and should you be worried that you need to go out and resample to have the most up-to-date information, especially if you're looking at things like flooding events or other high magnitude events that could drastically change the system. So I know I went through a lot there, and I wanted to just give you guys an overall general view of what we're doing here in Missouri with this project and these gears that we're using. Really excited to take this different look using all these emerging technologies for this project. But if folks have questions outside of this call, I'm happy to answer more about what we do or help folks if they're interested in acquiring some of these gears and using it for whatever projects they might be interested in. And if so, you can contact me at my email here on the screen. But I think I should have plenty of time for questions if folks have them now. So thanks again for listening in today.
Yeah, thanks, Tyler. That presentation was awesome. It's really cool to see what you guys are doing out there. I also really like the 360 view. The Google Maps for Riverscape seems pretty awesome and be a really good tool for monitoring.
Yeah, it really is a really cool tool to use. Again, the biggest difficulty is like, how do you portion those images? Because you take dozens of those as you're floating down the river, so they're all the same size, and each image represents the same amount of area. Is been the bigger difficulty with that. But qualitatively, it can offer a lot. We've already talked about using it similar to Google Street Views and having these tours for folks to use. It's like outreach, where if you want to kayak an area or you are interested in fishing habitat, you could use this imagery to help get at that.
All right, and I'm seeing Mari has a question. Where are you posting it for stream view?
That's a great question. We haven't gotten that far yet. There has been some, like, not with this project. We had a similar project earlier that was developing a fish sampling protocol, and he was posting some of these tours essentially with a GoPro, but a similar idea just on Twitter. But we haven't really developed anything too concrete yet.
Right. Yeah, I was wondering about data management a little bit. It seems like that's a whole lot of data.
Yeah, data management is kind of a nightmare. Yeah, the zoo doesn't have a great data management plan right now for this, and we're trying to work on that. But there is a lot of, obviously, data. We routinely generate 10 to 15 gigabytes of data per trip out, so that starts to add up quickly.
Yeah, no doubt. All right, let's get some more questions. Colin asks, Earth Views has a bunch of stream areas with 360 images across the U.S. So he's just giving you a little tidbit.
Was that, you said Earth View?
Yeah, Earth Views.
Okay.
And it's in the comments too. I can send this to
awesome.
to you, Tyler. And then Don actually mentioned too, Earth Views by Brian Footen has done a 360 photo project from a kayak for Puget Sound and some other places around the U.S. So that's pretty cool. We'll get that to you too. And Jen also dropped Tyler's email in the chat, and we'll include that in the follow-up email too, so you guys can reach out.
Yeah, we were.
Go ahead,
I was going to say, we were hoping to use Google Street View because there are some clips of people doing it on streams, but recently they changed how they accept third-party data, which has made it difficult for us to find a way to, one, generate the 360 views. It's hard to use that now, and two, upload it to their servers. So, but we were hoping to have something like that, where if you're just looking on your Google Maps, you could find it there. So.
All right, all you biologists, send out your info to Tyler. John Arterburn, I see you have your hand up.
Yeah, hi Tyler. Great presentation. Been following your work for a few years now. I've seen some of your other literature that you put out, and kind of on the cutting edge of this stuff. And it's an interesting approach for sure. I was just curious if you've done any comparisons with green or red LiDAR, and in particular, have you looked at which one's more cost effective and efficient at getting the answers that you're after?
Yeah, so that's a great question, and we do anticipate incorporating LiDAR into this. That's kind of the next step. We're kind of wrapping up the data collection we can do in the field with these gears. We plan on introducing whatever LiDAR we have available in the state, which thankfully most of Missouri's got LiDAR coverage now, as well as other satellite imagery and watershed use data sets that are out there in addition to this to give folks not only gears that they have to go out and use, but other publicly available stuff in this one, package where we can get as many different metrics of interest answered at one time. But we really haven't started to investigate too deeply into LiDAR yet.
Okay. One other question I have for you is that have you ever done any work on trying to link your habitat work to fish survival or abundance?
Yeah, that's a great question. So I didn't mention it today. Another chapter of my dissertation is going to investigate fish assemblages in these sites and using the habitat data we're collecting and hopefully linking them together. We're actually right in the middle of fish sampling right now. We're going to sample all these sites in the spring and then fall again. One of the bigger questions I want to ask is, as far as like scoped, is gathering habitat 10 meters away from where you captured a fish or 100 meters, what's most relevant to determining where fish are at? And we really think utilizing this data and subsetting it to these different levels, this scope will help us to better determine what level do we really need to be looking at to determine what species we're going to expect to find in these rivers.
Sounds great. Look forward to the next installment. Keep up the good work.
Thank you.
We'll just make sure we cover this. Jen had asked if the protocol is published or is there aspects of it that have been published?
Nothing's published yet, but other than the models that we're developing specifically with these gears, a lot of these gears have been used in some aspect or another for sampling habitat. Might not necessarily be directly for fish. There's a lot of stuff in Europe where they're doing it for hydrology studies and things like that, particularly with the drone work, where they have really clear streams and they can start to do a lot more than we're capable with our streams. They can start measuring velocities and stuff like that with the drones. But all the gears we're using, there's some aspect that's out there that you can probably get more information on that's published. Just nothing of ours yet.
Okay. All right, cool. We'll anticipate your work being published. All right. Tilly asked, what size of sites are you sampling? Meaning like bank full width and length.
Yeah, so our sites are anywhere between 40 and about 100 meters mean wetted width. And the length of the site is 50 times that length. So anywhere between about 2 and 5 kilometers right now. And we're trying to get into small sites we can. We found issues because some of our gears, obviously, you have to operate a boat pretty reasonably. So some of our sites that we originally deemed non-weightable aren't always non-weightable. So we've had issues with that where we're limited on what gears we can use. But the goal is to get into as many and as wide range of sites as we can, just above your small creeks, but not quite like your Missouri or Mississippi River yet.
All right. Eventually. All right. I don't see any hands raised. Ooh, Colin. Hitting us with the big one. Okay. Following up on Tyler's comments on the 360 images, KCDNRP did compare habitat mapping on the Snoqualmie River by boat, compared to trying to extract info from the imagery, and found the images insufficient. That said, they do appear to be a good outreach tool. And then he provided a link too.
Yeah. Thanks for including that. Yeah, we're starting to kind of realize that with the 360 imagery. It's a great qualitative tool, but the same model workflow that we're doing for the drone, they're working with the 360 imagery. But the biggest thing is, again, that how do we reference it? There's no real reference to know what size of anything you're looking at is unless we had something in each image, which adds a whole nother ordeal that we're not necessarily wanting folks to have to do when they're in the field. We're trying to make this as easy and streamlined, but use the gears sufficiently to gather data for their various needs.
Great input, Colin. All right. Anyone else? These were great questions, guys. All right, cool. And like I mentioned, we'll add Tyler's email to the follow-up email so you guys can reach out if you come up with more questions or
yeah, that'd be
chat
great
with them. All right. Awesome, Tyler. That was a really cool presentation. Thank you so much for joining us, especially over your lunch hour.
Yeah, no problem. Thank you, guys.
All right, take care. All right, we will wrap this up with a couple of things, some news and reminders. News end, I am regrettably leaving my role at U.S. Geological Survey effective tomorrow. Amy Poles and Jen Baer will be stepping in to take over this project and the webinar series. I want to thank you guys for your participation in Fish Monitoring Work Group. It's been a lot of fun coordinating with y'all. I believe this effort is invaluable to the community and will continue in the future. So after this email, Amy will send a follow-up email with a link to the recording. Obviously, reach out to her if you have questions. Also, if you wanted to be added to the distribution list, just shoot her an email and she can get you on the list. Also, reach out if you have some interesting work you'd like to present or have a presentation recommendation. I mean, Tyler came from somebody who saw his presentation at Hawaii AFS, the big one. So we're really lucky to have gotten clued in on that. So send those to Jen and Amy as well. We're a resource for you guys. So let us know if you have suggestions and we can see what we can do. And then slide, Sam. Another little plug for the pit tag data analysis webinar series next week. The first session, Start Your Journey with Pit Tag Data, will kick off with presentations from Nicole Tancredo of Pacific States Marine Fisheries Commission in Patagas on using Patagas' advanced reporting system to query and download data. And then after Nicole's, Marika Dobos will elaborate on this topic. Marika's with IDF&G, and she's going to present on managing pit tag detection data with Microsoft Excel. And Jen dropped the webinar series program into the chat, so you guys can take a look at the overview of the schedule and then also do a deeper dive with some of the abstracts. So give you an idea what we're going to cover. All right, next slide. All right, the Fish Monitoring Work Group will reconvene in October. To close out for today, I'd like to give a big thank you to Tyler Hessler for presenting all of his cool work, and to our core team, task leads, and y'all, our work group. Enjoy the rest of your week. Thanks, everybody.
Thanks, Meg.
Thanks for all you've done for PNAMP, Meg.
Thanks, John.